Imagine this. You're standing outside on a sunny day. Nothing is touching you, no wind, no one pushing you, and yet the sun is applying a tiny force to your body right now. Not heat, not gravity, a real physical push. It sounds impossible. After all, light doesn't have mass. So how could it possibly push anything? The answer lies in one of the strangest facts in physics. Light has momentum. That might sound weird because we usually think momentum requires mass. A bowling ball has momentum. A baseball has momentum. A truck has momentum. But photons, the tiny particles that make up light, have no rest mass. Even so, because they carry energy and always travel at the speed of light, they also carry momentum. And whenever momentum changes, a force is created. Every time a photon hits an object, it transfers a tiny amount of momentum. Most of the time, that photon is absorbed. Sometimes it bounces off. Either way, the object receives an incredibly small push. One photon doesn't do much. But the sun sends around 100 billion photons through every square centimeter every second. That's an unimaginable number. Each one delivers an almost microscopic push. Together they create something called radiation pressure. It's tiny, but it's real. In fact, scientists have measured it. This isn't just theory. One of the coolest examples is a spacecraft called LightSail 2. Instead of using fuel, it deployed a giant reflective sail in space. When sunlight hit the sail, the photons bounced off it. Every bounce transferred a little momentum. Individually, the pushes were almost nothing. But in the vacuum of space, where there's almost no friction, those tiny pushes slowly added up. Day after day, the spacecraft accelerated using nothing but sunlight. No engine, no fuel, just light. Another mission, called Icaros, launched by the Japanese Space Agency in 2010, proved the same thing. It successfully navigated through space using a solar sail powered entirely by sunlight. That means light isn't just something we see, it's something that can move objects. Now here's the strange part. If sunlight can push a spacecraft, it's also pushing you, right now. The pressure from sunlight at Earth's distance from the sun is only about 9/millionths of a newton per square meter if the light is perfectly reflected. That's roughly the weight of a tiny grain of dust. So you'll never feel it. Gravity is more than 100 million times stronger. But the force is there. Every second you're standing in the sun, trillions upon trillions of photons are colliding with your body. Each one gives you an unbelievably tiny push. Even your shadow plays a role. Your body blocks billions of photons from reaching the ground. The area inside your shadow receives slightly less radiation pressure than the area around it. The difference is incredibly small, far too tiny for us to notice, but technically, your shadow changes how light pushes on the world around you. In a way, your shadow has a measurable physical effect. This idea has actually been known for over 100 years. In 1901, Russian physicist Pyotr Lebedev became the first person to directly measure the pressure exerted by light in a laboratory. His experiment confirmed something James Clerk Maxwell had predicted decades earlier using only mathematics. Light doesn't just illuminate the universe, it pushes on it. It's one of those ideas that completely changes how you see sunlight. It isn't just brightness, it's a stream of billions of tiny particles carrying energy and momentum across 150 million kilometers of space, and every time they hit something, they give it a push. So, technically, every time you step into the sunlight, the sun is pushing you, just not hard enough for you to notice. If this messed with your head a little, subscribe. There's more like this coming.